Most people give the little thought to the important role of mechanical air compressors for manufacturing, residential, industrial, and agricultural applications in the modern society. For thousands of years, the human lungs functioned as a form of air compressors, which people used to stoke fires. But the carbon dioxide in the human breath made it difficult to actually sustain fires. Plus, the practice of the metallurgy, the melting down of the metals such as copper and gold, require high temperatures. Over the years, companies involved in the manufacturing air compressors have incorporated other features, such as electricity and pneumatic energy, into the devices. The use of air compressor to facilitate the movement of large volumes of air through the 8-mile-long tunnel constructed for the Italy-France rail system highlighted the numerous possibilities for the use of air compressors in the industrialized world. Centrifugal gas compressors are dynamic machines that impart kinetic energy to process gas by accelerating the gas through impellers. The gas enters the impeller with a little radial velocity. The impeller import works of the gas by accelerating the gas from the eye of the impeller out toward the tip. The gas exists with a radial velocity equal to the tip velocity of the impeller. Then the claret is in the diffuser, and the energy is converted into the pressure. The gas is redirected to the next impeller and the return channel, or collected in a wallet and discharged through the discharge nozzle. Centrifugal compressors are employed in ethylene plants because they can handle very large volumes and are very robust, allowing for continuous operation in critical services. The process components are those that are in direct contact with the gas: the rudder, diaphragm, return bands, and volutes. These parts do the work required by the process. The mechanical components are the pressure containing and support system of the compressor, the casing, nozzles, and valves, journal and exhaust bearings, and seals. These parts allow the process components to do the required work safely and reliably. An integrally geared centrifugal compressor is a multi-shaft compressor in which each stage is a three-dimensional impeller operated at its optimum speed. The compressor type consists of a gear unit with a central ball gear and different gear pinions, which drive many impeller stages. Integrally geared compressors with high discharge pressures of up to 300 bars and a capacity up to 600,000 cubic meters per hour are offered by different vendors. Machines that also combine compression stages and expansion stages are available. Integrally geared centrifugal compressors provide many advantages, such as advanced high-speed impellers and a low cost and higher efficiency compared to other turbomachinery. They also offer near isothermal compression with an intercooler after one of the two impellers. In other words, they currently provide the nearest possible operation to isothermal compression compared to many other compression options. Therefore, they provide especially high efficiency. They are highly efficient because all stages are intercooled, and the speed increasing gears allow the stage to operate at a higher specific speed. Another advantage is to integrally geared compressors in the reduced number of stages required that still provide a higher efficiency. Many modern designs allow the rudder removal without disconnecting process piping. This sign operating and reliability benefits of integrally geared centrifugal compressors are discussed in this article. Compressors in process plants usually do not have spares and are considered critical equipment items. In most applications, compressor reliability is considered a high priority, and it is directly proportional to a plant's profit. Integrally geared centrifugal compressors, particularly those that do not meet American Petroleum Institute standards, usually have a relatively lower reliability when compared to the conventional API centrifugal compressors. Integrally geared machines are multiple bearings, seals and gear machines and operate at high speeds. In standard compressors, these usually cannot all be managed to achieve high reliability. Their reliability has been improved recently. Specifically, modern API integrally geared centrifugal compressors, designed and manufactured per API 617 and other applicable API standards, such as API 614 regarding lubrication oil system, have provided increased reliability and availability over the last decade.